Hey guys, hope you all are doing good. Today we are going to learn about the cloud computing. First, let us start from the introduction part, and I will be covering almost all the topics which comes under the computing part. Let us learn the introduction first. Computing is being transformed into a model consisting of services that are commoditized and delivered in a manner similar to utilities. Like utilities such as water. See, in the household parts, we are going to use the water and we are going to pay for the things we use. Similarly, electricity, gas, and telephony. In such a model, users will access the services based on the requirement, like it might be a minimum or the maximum, regardless of where the services are hosted. Cloud computing is the most recent emerging paradigm, promising to turn the vision of computing utilities into the reality. So, it is the technological advancement that focus on the way we design computing system. It is a concept of dynamic provisioning. What is exactly the dynamic provisioning? It is applied not only to the services but also compute capability, storage, networking, and information technology infrastructure in general. So, as you can see in this diagram, computing has like the storage part and it can be accessed via the mobile, and it will be having so many applications which are hosted by various service providers and some of the database, hybrid cloud, public and the private, which we will be discussing in the later part. And the server where it will be hosting. Now resources are made available through the internet and they offer pay per use basis. You're only going to pay for what all things you will be using. Okay, today anyone with a credit card can subscribe to the cloud services and they can deploy and configure the servers for an application in hours, growing and shrinking the infrastructure serving its application according to the demand, and you will be only paying only for the time these resources have been used. Now let us see how it emerged as a cloud computing utility. This vision of this utility is based on a service provisioning model which was anticipated the massive transformation of the entire computing industry in the 21st century. Okay, computing services will be readily available on demand just as the utility services such as like water, electricity, telephone and the gas that are available in today's society. Similarly, users need to pay to providers who provide your applications only when you access them. So, in addition, consumers no longer need to invest heavily or encounter difficulties in building and maintaining complex IT infrastructure. If you see the computing model, we are going to have some of the deployment models defining attributes, resources, infrastructure, and delivery models. What is the vision? What is the main part of the cloud computing? Is it allows anyone with a credit card to provision virtual hardware, runtime environment, and services that are used for as long as needed with no upfront commitments required. No upfront commitment means it refers to a pricing model in the cloud computing where like users can access resources or services without any long-term contracts or upfront payments. So these are yeah, that one, and the entire stack of a computing system is transformed into a collection of utilities, which can be provisioned and composed together to deploy system in hours rather than like days, and with virtually no maintenance cost. So if you see the cloud computing vision in a diagram, like some of the people are like, we want to host the applications, where can we host? And some of the peoples are like, we want to access some of the applications, where can we access? And some of the people will be having the more amount of infrastructure and they want to make use of it. So for every type of things, this plays a major important role. So when we define a cloud, cloud computing refers to both the applications and the hardware and system software. So, application delivered as a service over the internet, whereas the hardware and system software in the data centers that provide those services. And cloud computing has become a popular buzzword, and they are being used widely for different technology, service, and concepts. And the term cloud has historically been used in the telecommunications, and it became the symbol of the most popular computer network, that is the internet. So this is another one diagram where like a platform as a service, software as a service, no capital investments, and all. So, we can define three criteria to discriminate whether a service is delivered in the computing style. So, firstly, the service is accessible via a web browser or API, application programming interface. So, secondly, there is like zero capital expenditure which is necessary to get started. You only pay for what you use as you use it. So if we like look into a closer to the like cloud computing, it is helping enterprises, governments, public and private institutes in so many ways. Like some of the examples are like large enterprises can offload some of their activities to the cloud-based systems. Small enterprises and startups can also afford it, and system developers can concentrate on their business logic rather than dealing with the complexity of the infrastructure. End users can have their documents accessible from anywhere and any device. So, if you see, this is the public cloud. What is public cloud and all, I will be discussing in the later part. Just concentrate on the thing which I will be telling here. So, these are some of the clients who will be accessing the cloud. So, there will be a cloud manager who will be, like managing all the things and all the uh, infrastructures, and it will also provide some of the other cloud services. And so, there are three types of clouds: public, private, and the hybrid one. So, in the public cloud, they are the most common deployment models in which the necessary IT infrastructures are established by some of the like third party service providers, and they will make it available to any consumer on a subscription basis, that is pay as you use on basis. Okay, such clouds are appealing to the users because they allow users to quickly leverage compute, storage, and application services. So now it comes a problem for the large organization that own a massive computing infrastructure. They also can be still benefited from the cloud computing by like replicating the cloud IT service delivery model in house. This has given a birth to the concept of private cloud. And whenever like private cloud resources are unable to meet users quality of service, then comes the hybrid cloud. So this is the diagram for it. So now there are three types of reference model, where IaaS, PaaS, and SaaS. So now first comes the infrastructure. This is the base. So it's the solution delivers the infrastructure on demand in the form of virtual hardware, storage, and networking. These are only created at the user's request and on the provider's infrastructure. And users are given some of the tools and interfaces to configure the software stack installed in the virtual machine. Next comes the platform as a service. So, they're the next step in the stack. They deliver the scalable and elastic runtime environments on demand and host the execution of applications. These services are backed by a core middleware platform that is responsible for creating the abstract environment. And next is the software as a service. They are in the top and they provide application and services on demand. Some of the like common functionality of desktop applications such as like office automation, document management, photo editing, and CRMs all comes under SaaS. So now let us see some of the characteristics and the benefit. So as I mentioned, no upfront commitments, on-demand access, nice pricing, simplified application, acceleration and scalability, efficient resource allocation, energy efficiency, and like seamless creation and use of third-party applications. So what are the challenges which we face? Like any new technology which develops and when it becomes popular, some of the issues have to be fixed. So, new interesting problems and challenges are regularly being posed to the community, including IT practitioners, managers, government, and regulators, which are mainly related to configuration, networking, and sizing of the computing systems. Technical challenges also arise for the cloud service providers for the management of large computing infrastructures. Security, in terms of confidentiality, secrecy, and protection of data, is also another important challenge. So, yeah, this is the historical development where uh, there are five core technology, that is the distributed system, virtualization, web, service orientation, and utility computing. So this is the historical development which is seen in the graph, and yeah. Distributed system means it is a collection of independent computers that will be located in the different parts, so that appears to the user as a single coherent system. So its benefit or its properties are heterogeneity, openness, scalability, transparency, concurrency, continuous availability, and independent failures. So in distributed system, it is mainly divided into three major things, that are the mainframe computing, cluster, and the grid. So in the mainframe, as you can see, uh, it is a subpart of the distributed system where they are the powerful, highly reliable computers specialized for large data movement and massive input output operation. These are the first example of large computational facilities leveraging multiple processing units. So, they are mostly used by the large organization for bulk data processing task. Next comes the cluster. So, cluster is a collection of tightly or loosely connected computers that work together so that they act as a single entity. Okay, these are generally connected through LAN, so local area networks, and it started as a low cost alternative for the mainframes. As you can see in the figure, there is input data which is connected to the computer, and computer, this is the master node or the root node. It will be having the replicated slave nodes, and in the last there is the result. Okay, these machines could be connected by a high bandwidth network and controlled by specific software tools that manage them as a single system. So next, the grids. Grids, it appeared in the early 90s, and users can consume resources in the same way as they use the utilities. Grids initially developed as aggregations of geographically dispersed cluster by means of internet connections. Okay, they are proposed a new approach to access large computational power, huge storage facilities, and wide variety of services. So now let us look into virtualization. Virtualization is another core technology. It means to create some virtual version of an underlying system with the help of virtualization. Like multiple operating system and applications can run their applications on the same machine and its same hardware at the same time. This increases the utilization and flexibility of the hardware. One of the main is they are cost effective, hardware reducing and energy saving techniques. So they allow sharing of a single physical instance of a resource or an application. The most common example what we can see of the virtualization is hardware virtualization. So things have been changed when the web application came into its emergence. So Web 2.0 is the business revolution in the computer history. So it caused by the move of the internet as a platform and any attempt to understand the rules for the success on the new platform. The web is the primary interface through which computing delivers its services. So it brings interactivity and flexibility to the web pages. Like nowadays we have web pages, and inside that we are going to get a hyperlink. By clicking on that, we will be directed to another page. This and all are some of the like revolutionary happened in the web pages. So some of the example if we see, then there are the Google Documents, Map, Flickr, Facebook, Twitter, and YouTube, etc. So, the next comes our service oriented computing. So, they are the core reference model for computing system. This approach adopts the concept of services as the main building blocks of application and system development, and it supports the development of rapid, low cost, flexible, interoperable, and evolvable application and systems. It introduces and diffuses into two important concepts. They are quality of service and SaaS. So SaaS we have seen before. So now I'm only going to discuss about the quality of service. So it identifies as a set of functional and non-functional attributes that can be used to evaluate the behavior of a service from different perspectives. These could be performance metrics such as like response time or security attributes, scalability, reliability, and availability. So next comes the utility oriented computing. So it is a vision of computing that defines a service provisioning model for the computer services. Invest resources such as storage, compute power, application, and infrastructures are packaged and they are offered on a pay per use basis. So, utility computing is a service model that provides computing resources to the customer on demand, and they will only charge for the services used instead of a flat rate. So, now building cloud computing environments. So, the creation of cloud computing environments encompasses both the development of application as well as the systems. So, first, now let us look into the application development. Applications that leverage cloud computing benefit from its capability to dynamically scale on demand. So, one class of application that takes the biggest advantage for this feature is the web application. Their performance is mostly influenced by the workload generated by varying user demands. So, there are two types of applications mainly, that is the resource intensive application and the scientific applications. So, now next look into the infrastructure and system development. So, here distributed computing, virtualization, service orientation, and web form the core technology enabling the provisioning of the cloud services from anywhere on the globe. Distributed computing is a foundational model, and the infrastructure as a service solution, it provides the capabilities to add and remove the resources, but it is up to those who deploy the system on the scalable infrastructure to make use of such opportunities with wisdom and effectiveness. platform as a service solution embedded into their core, offering algorithms and rules that control the provisioning process and the lease of resources. And computing platforms and technology. So we are having a Amazon Web Service, which we will be discussing in the future, like in the fifth video of this. So, in a brief, it offers the comprehensive cloud IaaS services ranging from virtual compute storage and networking to the complex computing stacks. Okay. Next, AWS is mostly known for its compute and storage on demand. We will be having, like EC2, that is the computing demand services, and simple storage service, which we will be learning in the fifth video. And we are having the Google App Engine, which is a scalable runtime environment, mostly devoted to executing web application. Then comes the Microsoft Azure, and this is also like it provides a scalable runtime environment for the application and distributed applications in general. Hadoop is an implementation of MapReduce, an application programming model developed by Google, and Force.com and Salesforce.com. They are the cloud computing platform for used mainly for developing social enterprise application and customer relationship management. Aneka is a cloud application platform for rapid creation of scalable applications and their deployment on various types of the cloud in a seamless and elastic manner. It also supports, like programming abstractions for developing applications and a distributed runtime environment that can be deployed on heterogeneous hardware. So, I hope I have made clear with all the platforms, infrastructures, technologies, and so on. So, this is what is the first introduction part of the cloud computing, and just keep revising it till I upload the next video. So, this one is the basic thing which I have taught you. In the next upcoming videos, we will be discussing more about the cloud computing, the reference model it might be, or the delivery, or the infrastructure, whether it might be anything. We will be going in depth. Do not worry about that. So, till then, just keep revising. If you have any doubts, feel free to ask me in the comment section. So, this is all for the introduction part. Hope you guys have understood, not fully, but like half of it, or might be, three-fourth of it. So, the main thing is you have to revise. Without revising, you can't remember the things. So, yes, guys, so keep revising, and any doubts, you can just keep me updated in the comment section, or if anything you find it you wanted the details of it, just let me know. Thank you for watching. Have a great day ahead.